Hi, today I would like to show you how you can load Grasshopper file in Python through compute.rhino3d service, which I found that you can actually do that using compute.rhino3d in this website, in this forum, in Rhino discourse, and I tried it out with the local compute Rhino server, and it worked great. So I'd like to show you how you can do that. Now, first of all, you have to have a Grasshopper file that you want to load up, and you have to save it as GHX file, which is a ASCII format, which you can open it and parse it through a text editor. And I made a really simple definition here, making this kind of Voronoi tiling in 3D with 4 sliders, 4 inputs, like this. And it's pretty simple. I mean, you can use any kind of components which is installed in Rhino, which is installed in Grasshopper. And the only thing you have to be careful about, a few things that you have to be careful about, is that first of all, you have to save the files in GHX format, which is an ASCII format. And also for the input that you want to control using through API, you have to make a group to whatever component that you want to control of, or whatever component that you want to input by yourself inside through API. You have to group the component like this. For example, I grouped 4 types of components, 4 primitive components with group. And also the naming convention is pretty important as well. For the name of the group, for input, you first have to type capital RH_n and colon plus a name of your parameter. The name of the parameter could be anything, any name that you want to use. So I have 4 parameters. First, the count of Voronoi. Second, the size of the tiling. Third is the outer height of the tiling. And fourth, the inner height of the tiling. So I have these 4 parameters set up as input by grouping component one by one with the right naming convention. And also you have to have one more grouping for the output. I mean, you could have many output as possible, I think. For now, I have only one output, which you can retrieve it from through the API as a response. And I have now this one, which is a brep result. The Voronoi tiling itself as a brep or surface, trimmed surface. And the naming convention comes with RH_out colon. You always have to have this word, letter, plus a name of the output parameter, which could be any name that I named it Geo. So that's the file that you have to make. Anything else, everything else, you could do as much anything as you want. I mean, you could use any kind of components using like any input or any transformation, any surface or brep mesh modeling stuff. You could also use plugins as well, as long as your Grasshopper is installed in your computer or in your server, which you have installed compute.rhino3d. Now, once you're ready with the Grasshopper file, you have to run up your compute Rhino server like this. I am running the server right now using a under the local server by installing the Rhino working in progress inside this computer, inside this Windows computer. And in order to install it, you need to have a license for Rhino 6 currently. As long as you have it, then you can install the Rhino work in progress in your computer. Then follow the instruction in the page under rhino3d.com compute, and if you go to the Git page, GitHub page, there's a link to installation guide. Under here you can follow the instruction to install the compute.rhino3d in your computer. So follow that to install it and run it on your PC, then you're good to go to try that out. Now the detailed instruction, I have previously made a video about how to install it and how to use the basic command for compute.rhino3d for Python and Unity. So if you're interested in that, then you can go back to watch those videos. Today I'm just going to tell you how you can load Grasshopper file through this service. Now, once you're ready with your Grasshopper file, let's start writing a Python script. Now, I have already saved the GHX file in the folders, and I'm gonna make a new Python script to actually load this Grasshopper file and probably save it into a 3DM file through API. Okay, I'm gonna name this gload test. And currently I'm using Python 3.6, version 3.6 or 3.7, maybe 3.7. If you're using PyCharm, which I'm using right now, you can go to the settings and under a project gload test, there's a item called project interpreter, and currently I'm using Rhino Python 3.7. I think you could still use 2.7 as well, but for now, for this example, I'm using Python 3.7, and you also need to have some modules in order to connect with compute.rhino3d and deal with Rhino 3DM files. So if you ever use PyCharm, you can go to this plus icon, which is an install icon, and search for compute Rhino. Doesn't show up because I've already installed it, but hit this one, compute.rhino3d. Install this compute.rhino3d first, then also install Rhino 3DM modules as well, which you can control, which you can make a Rhino 3DM files through Python and save it as a file or load a file. Now, once you have installed it, let's start importing the modules that you need to use here. First, let's load the Rhino 3DM. Also import requests, which is used to call the API through the REST API. Also import base64 in order to decode and encode the text into base64 text strings, and also import JSON. Now, if you don't have any of those components or modules installed, then you have to install it through the interpreter settings that I showed you in PyCharm, or if you don't have a PyCharm, then you might need to use a command line manage package manager like pip. Okay, so this one is already installed, so I don't need to install it, but if you don't have it, use package manager like pip or anything else to install those modules. Also, let's import compute.rhino3d and specifically brep, which I might not use it, but just in case. Or no, util. Okay. Now, first of all, let's set the URL for the API call. First of all, let's set the URL for the compute.rhino3d server API, which you can set it like this: compute.rhino3d.util.url equals to, if you're using the local compute.rhino3d server, then you can use the local server address like this. If you're using a remote server like the one in AWS or something, then use that address to write it here. For local, it's like this: 127.0.0.1:8081. That's the address for the local. And also I'm gonna set the auth token. Since I'm not using the remote, I'm gonna make it empty. I don't need any authentication here because I'm using a local server. And I'm gonna create I'm gonna create a URL for post request, which is compute.rhino3d.util URL, which is same as this one, plus, okay, I need a slash here, plus Grasshopper. So this is the endpoint, this local server address plus Grasshopper is the endpoint to upload your Grasshopper file. And also next, let's load up your Grasshopper files, which is in this directly, the same directly as the Python file. I'm gonna use the open and open Voronoi GHX mode as read, and encoding I'm gonna load it up as UTF-8, and I need to import it. I need to load it without the BOM, BOM. So I'm gonna encode it as UTF-8-sig, which will import the GHX data without BOM. Okay, and read the file like this. Now let's check it out if I got it correctly by printing the data. Now let's run it and see if I got it. Okay, so I have loaded the GHX file correctly for now. Now the next thing I have to do is to encode this into a base 64. And in order to do that, first of all, I need to make this text file. Currently I have imported the file as a text file, string, and first up I have to convert it into a string, to a binary first in order to make it a base 64. So to make this string a binary, the simplest way is to, I'm gonna name this data bytes by calling encode on string and encoding it as UTF-8 will encode the string into a byte. So let's check it out again. Data bytes. And you can see that you have now this B character on the front of this string, and which means that this is a binary. Now I've successfully converted into binary. The next thing I have to do is to encode this into a base 64. So I'll name this encoded, and I'm gonna use base 64 modules to B64 encode this data bytes that we have just made. Right, and let's check this out again. Encode it. And now we have successfully encoded the GHX file into a base 64 data. Now, next thing I would like to do is to create a JSON files for parameters that we want to use as an input. So when you look at the Grasshopper files, we have currently 4 inputs. So we want to have 4 input parameters to be listed in as a JSON that you want to send it through API in order to control the GHX file. So let's do that by writing up the JSON file. Now, the format of the JSON is already defined by a McNeil. If you go to this course, if you look at here, this is the basic information which tells you the format of the post request. You need to have 3 fields. First, algo, which is a, as it says, bit 64 encoded string containing entire GHX files. Also, a pointer. If the algo doesn't exist, then could be a URL of your GHX file. And then values. The values are the parameters for the input, which you have set it here. These 4 inputs. Now, let's do that. Let's write it up. So, the first one, algo, we have just encoded the text, the GHX text into a encoded base 64 encoded data, which is still a binary, but as it says in the discourse, it has to be strings. So I need to decode this again into a UTF-8. So I'm gonna make another file, another variable called decoded, and I'm gonna decode this encoded base 64 encoded one into a readable text using a UTF-8. Okay, and let's check this out again. Okay, let's comment this out. You play this. Okay, I have, okay, this is not 9, this should be 8. Now you have a base 64 encoded values into string. So it's ready. So now I'm gonna make a JSON file. First, algo, be decoded, then pointer. Since you already have a file, decoded file here, decoded string here, you don't have to have you don't have to have a pointer here. So yeah, I'm gonna set it to none. Then values, which will be a input values, input parameters. And since we have 4 inputs, I'm making it as an array, and each array consists a object like this. So we have 1, 2, 3, 4 objects, 4 inputs, which is Rhino count, size, outer, inner. Okay. Now, the format is pretty much defined. What kind of values that you have to type is already defined, and I'm gonna tell you what's needed here. First of all, you have to have a key called param name, which corresponds to the name of the parameter input, which is, for the first one, rhn colon size, just this one. So you just have to type in the same name as write it on the group for the input. Next, you have to you have to write up the values, the initial values for those components. I mean, currently in this Grasshopper files, sliders are inputted, but when you load it up inside the API, these slider values will be ignored, and any value that you type in through API will be used for those components. So consider that these sliders are just a test input inside a Grasshopper file that you see here. But through API, you just have to care about what numbers to input into these boxes, not considering the sliders. So go back, and the key value that you have to type is inner tree. And the first thing you have to type in is the name of your data tree, the address of your data tree. And since I'm gonna make the values into 0 address, which means this address, 0 is fine for this one. If you want to make it complex, you can change it to other values, but for now 0 is fine for me, so I'm going to type it as this, 0 semicolon. So that's the key for the value, another key for the value, and then make an array like this. And inside the array, you make another object. And if you want to input a number, then first you have to set up the type of your value. If it's like .3d, then you have to name the type of the object .3d rhino.geometry.point3d, but for now I'm just gonna type in the value, the number values. So the type of the number value will be system double. So the name of the type will be the class name of the value in C# or .NET. So follow that convention. Then another key value that you need to have is the data, which is the actual data that you want to input. And even though the value is in numbers, you have to type it in as a string. So if you want to input a number 100, then write it as a string with the double quotations like this. So, and this will be the one set of values that you want to input inside this box, the variable box, the primitive box. So if you want to input multiple values, you can just make like this, put as much number as you want like this, which will treat it as a multiple number. But for now I need just one number, one single number, so I'll keep it as a single number like this. What I need to have now is other input values, count, outer and inner, so let's write those values. The easiest way, you can just copy those values here and paste it here. and just change the name and the type of value and the actual data value. So for this one, this is count. It's not a double but integer. And the number of the Voronoi, maybe I could do with 50. And for the value outer, the double is fine. I'm gonna set the number to 50. For inner, let's say I'm gonna set it to 10. Now, the JSON format itself is done like this. I think this is okay. Now, as soon as you make the JSON file, you can call a post. You can send a post REST API, post request through REST API using request modules. So response equal requests post URL JSON equal JSON. Okay, it should be fine, and let's check out the result by printing out. If I run it. Okay, I got this response to 100, which means successful. Let's also print out the content. Run it again. Now I seem to have a bunch of data like this. I'll go pointer, values, and this time the parameter name is lhout colon geo, which is the output values that I set inside this Voronoi here. So it seems to get the right value here, and the type of the data is rhino.geometry.brep. It's fine. The data itself is written in some binary format. Could be a base 64 format. So I have to decode it again into a readable format. Now, I seem to get the content correctly, so let's decode it and actually use it. Maybe save it in a 3DM file. So, first thing what I could do is to, since the response itself is a JSON or string, so first of all I'm gonna decode this value, which is a binary data, into string first. So I'm gonna name it response content decode to UTF-8, which will convert the binary to string, then convert that string into JSON using JSON loads res. Now let's check that data again. Okay, seem to have there seemed to be a problem here. Attribute dict. Okay, since I named this JSON file here JSON and the module names is also JSON, I have to change the name of this JSON file. So I'm gonna change it to JSON data. And also change this to JSON data. Then run it again. Okay, now I've converted the data into JSON, which you can get the values pretty easily. If you just want to read out the values here, then you can just use a square bracket and to access this dictionary like this. Now, since values contains multiple geometries, multiple outputs, so I'm gonna use a for each for val in values. For each values, the param name exists, so I'm gonna retrieve the param name. Let's check out that again. Oops. Yeah, I have to set the values. So values will be the rest values. So the only param names that I have here as an output is outH, outGO, which is this one. Now let's look at the other value, which is the data. And as you can see, the other key you have to look at is the inner tree, which is same as an input format. The output format is same as an input format. So let's look at the inner tree. Let's retrieve the data as an inner tree variable. Like this. And for key and intervals in inner tree items. This inner tree is a dictionary. Let's print out the key first. Then also check the intervals. Let's run it. Okay. So this is the param name, this is the key, and which is the data tree address. And this is the actual values under this address, data tree address. Okay. Now since this is also a array, I'm gonna make another for loop here for interval and intervals. The actual data is json.load interval data, which is this one. I don't need any other information like this one. Yeah, so this is the actual data that we want to import here. And let's check that out again. Print data. Let's run it. Okay, so I have several geometries printed out on a console. And the reason why I have multiple geometries is because if I look at this here, I have like 80 trimmed surface inside this boxes, inside this primitive geometry component, and I must have 80 values listed here as well. Now, Now that we have a geometry, each one is probably a brep. List is listed as a string. We have to convert it into some object that you can read it as an external file format. And I am going to convert it into 3DM file. So in order to do that, first I have to make an empty 3DM object, model equal rhino3dm dot file 3dm, and after you retrieve the data, I'm gonna convert it into a rhino3dm readable object by decoding it. So I'm gonna use the function under common objects decode for data, which will decode the data into readable object. Let's check that out again. I'm gonna comment this out, run it. See that now the object has been decoded into some kind of object, Python object, and you can see that each one is a brep here. Now that I have the decoded object as a brep, I am ready to add it into a rhino3dm file, which is this one. So model objects.add geo will add all the brep files into this rhino3dm file. And after you have added all the files, saving the 3dm file into any directly like voronoi.3dm and run it. The voronoi3dm file will be created, and if I look at it, if I load it up, if I open it up, I have actually got the result from the Grasshopper files like this. So the input was like I have 50, I should have 50 cells, Voronoi cells, and the scale is around 100, the size around 100, and outer value, outer height is 50, and inner height is 10, and so on. And looking correct, but let's change the value count to 10 to see if the value will change. Let me close this thing and run this again. Run the object, run the script, and see if the rhino3dm file have responded to it. And you can see the Voronoi cell has changed to number 10, and which proves that it has correctly been used. The Grasshopper file has been correctly been used by sending the parameters like this through API. Now this is the static way to use the load Grasshopper files without opening Grasshopper or Rhino. But if you just change the more like a user interface or anything, you can interactively change the values for the Grasshopper inputs and interactively retrieve the data, the result, as a mesh or anything. You can use web apps. You can also use it inside Unity or Unreal Engine game engines like that. if anybody is interested, I could also create a tutorial for Unity as well, which I have already tried it out, and which was pretty easy as well as you do in Python. So, and there are much more possibility using inside Unity as well, which you can export it into WebGL as well. So that's it for how to load the Grasshopper files using Python. It's pretty easy. Once you are able to run compute.rhino3d on local server or remote server, after that it's pretty easy to deal with the Grasshopper files just by sending the GHX file. I hope this video is helpful for you. If you have any, all the files that I created here will be uploaded, can be accessed through a description, and there are previous videos explaining how to use a basic compute.rhino3d as well for Python and Unity 3D. So if you're interested in that, you can also watch that as well. Okay, thank you. That's it.